Just a quick intro into myself. I'm Guillaume Aimetti. I have a PhD in computer science with special research into machine learning, specifically audio processing for speech recognition. Following my PhD, I was 3 years as a consultant at Deloitte, where I was working on a lot of data science projects for big multinational clients. And since 2016, I'm co-founder and CTO of Inspirient GmbH, and we're based in Berlin. Okay, so why would we want to automate data science? Everybody knows that it's very laborious. It's very costly. It takes a lot of time, and it takes a lot of knowledge to get it right. And actually, a lot of it is quite boring work for a data scientist. According to Isaac Faber, the chief data scientist for the Army, the US Army, he states that everybody knows that 80% of data science is data cleaning and prep, and actually only 20% of that is actually doing analytics, and 80% of the 20% is summary statistics. So the really fun parts kind of come at the end. And so if we were able to automate the time-consuming tasks, the data cleaning parts, the summary statistics, maybe we would have more time to actually do more of the fun parts, which is training models, and actually delivering value from a data science project. The interesting thing that Isaac also says is at the beginning of any data science project, everyone begins with just a basic table or a spreadsheet or a CSV file or an Excel file. And he even says that you're actually emailing them between yourselves. And if you're collaborating with multiple people, at the very beginning, you will pass an Excel file between you, and you'll enrich it together, you'll clean it together. If you're collaborating, some people who work alone will obviously skip the email part. But as a consultant, this was the process that I took. So at Deloitte, we would very often get a database extract from a client. It would be in the form of a CSV file. And the first thing we would have to do is assess the quality of that data. We would sit down and with a senior person and hypothesize about where the interesting insights might be in this data set, come up with our assumptions. And then we would spend some days, if not a week or two, then really diving into the data and answering these assumptions, and coming back up after that time, reviewing the results with our manager, and then coming up with a new set of hypotheses, and then going back down into the data again for some days. And then we would hope that by the end of the allotted time for doing these initial analyses, we would have found something valuable for our client. It was always, most of the times, a big scramble at the end to really find the key insights. And this comes to the second problem. But when you're working with larger data sets, so Pascal Bournet is actually a thought leader of AI and automation. He was the head of AI at McKinsey. He's on the Forbes Technology Council. And he points out that, yeah, if you don't automate the data exploration process, you put yourself at risk of missing the most valuable insights. As data is getting bigger, it is growing at a compound annual growth rate of 40% every year. And the dimensions are getting more and more. So the number of questions that you could possibly ask of a data set is just growing and growing. And right now, a human trying to analyze such data is just not scalable. And you really the only way to solve that problem is through automation. And yeah, how would we automate then such a problem? Well, data science has come very far in the last years, the last decades. We're very good at problems like recognizing handwritten digits. You give a model, a classifier, you train it with some handwritten text, digits here, and actually the accuracy of recognizing such digits is very high. And you can do that very easily now. You can do it with a few lines of code, build yourself a digit classifier, and do that very well with a very high accuracy. Another thing that you can do very easily with a few lines of code is build yourself a classifier for recognizing emotion from images. And not only emotions from images, but also emotions from text, such as tweets from Donald Trump. You could also build yourself a lying classifier to see if a tweet is true or fake. And even more impressive is that we have cars which are able to drive by themselves on a road with real life objects moving around, people, other cars, animals running onto the road, and it does that all in real time. I mean, this is so intelligent that we can have a car that can do all of this in real time and do it in a safe way. And with all these examples of data science doing really great things, as a consultant, one of the things that really annoyed me when I got this CSV file from a client and I wanted to import it into Excel or Tableau to do my analyses, the first thing it asked me is, what's your delimiter? Is it tab? Is it semicolon? Maybe you've also experienced this. And I wondered, how can we have a car that can drive itself on the road, and yet we are asked what kind of delimiter is in our CSV file? And so, taking this problem a little further, why not create yourself a classifier for detecting the delimiters in tables? And kind of this is where we started. This is where you would start if you want to start automating data science. You have to start at the very beginning of the data science process, and the first thing you have to do is import your data into whatever tool you're using. And so, if you want to automate that, you have to be able to detect what the delimiter is. And I mean, the number of classes for such a classifier is really not that many. You could have a tab, you could have a semicolon, you could have a comma, you could have a space, maybe another character, but it should be very easy to classify. And we did it, and it actually is very easy to classify. Okay, so at the beginning of automating the data science project, the first thing you would want to do is be able to import data. So you've built yourself a classifier for detecting the delimiters in tabular data. The next thing you might want to do is classify what kind of a table is this. Does it contain time series? Is it sensor data over time? Is it bank transactions over time? Is it a profit and loss statement? Is it geographical coordinates over time? Is it tracking your one of your devices over time? It could be any number of different types of tables, and you can build yourself also a classifier to detect what type of table you're working with. And then if you have a classifier that tells you what kind of table you have, then you can also decide what kind of analyses make sense based on the table that I have and the dimensions that I have in this table. So if I have transactions over time, then I know that it makes sense to draw a time series. If I have geographical coordinates over time, then I know that I could do a geographical analysis, draw a map and the direction of my movement over time. And so once we've automated our analyses, the next part of the process would be to then build a classifier for detecting patterns in these analyses. And there are a number of different types of patterns, and these patterns can be applied on different types of analyses. So if you have a time series analysis, you know that you should be looking for deviations in time. You should be detecting trends. You can also do very specific analyses like fraud detection types of analyses like Benford's law, and the correlation analysis and look for outliers from the correlation. There are a number of types of patterns and they are finite. And so you can build a classifier for each one of these patterns and apply them on the analyses. And so what do we get? Well, if we are able to automate the full data science process, this allows us to be very opportunistic about the analyses that we do, whereas previously we would have always chosen carefully which analyses we want to do, because it's such a big time investment in analyzing any data set. But here we can say, okay, let's just find the data set and throw it in and see if we find any interesting patterns. And so, for example, there are many data sets online. This one is a publicly available data set from the United States Environmental Protection Agency. It's the emissions from different types of cars. So they test many of the cars that you can buy and test for different types of emissions like CO2, nitrogen oxide, and so forth. And if you download this data set from the publicly available, from their website, the EPA website, you can then look to see if there are any outliers in here. And actually, if you would look through that data set, you would find that the Volkswagen Touareg is actually an outlier car, because it actually emits far too much nitrogen oxide. And maybe you're aware, but the CEO of Volkswagen, yeah, they got into trouble for trying to hide this. But finding it would have actually been very easy using automated data science. And as a human, maybe you would only have tried to look at that if you had guessed that something was going wrong in the first place. So how many classifiers would you need for automating the full data science process? Well, in our engine, we have around 300 classifiers, and they enable us to get from raw tabular data to the insights into the data. And these classifiers, they each do one very specific thing, and they allow us to reason about a data set. Does it have, as I mentioned earlier, does it have time series? Does it have geographic data and this kind of thing? And with these 300 classifiers, we can then apply all of the relevant analyses that one would want to do. For those 300 classifiers, we can manage within our engine to do everything that you would do in Excel, all your bar charts, your time series, your correlations, your geographical analyses, and a few more that you can't do in Excel. Like, for example, the the network analysis down there in the bottom right. I'm not sure if you can do text analysis in Excel, but you also could do that with your engine, and so it's allowing you to also go a little bit further than one could do in Excel. And what do you do with these insights? So now that insights have become cheaper to obtain, you can be, as I said, opportunistic. And for example, at Deutsche Bahn, this was the first time I really felt like an agile data science process take place here. And I had been at Deloitte for 3 years selling agile data science, but it wasn't truly agile. This was truly agile. So we met Deutsche Bahn, the Stations and Services AG, and they're in charge of tracking how if there are any issues within the train stations. So they walk around and do inspections of all their train stations. They have about 5,000 stations in Germany. And somebody is tracking if there's graffiti, if a lift is broken, all these kind of things. And when we met them, they had been tracking these issues on iPads for the last 6 months. Previously, they were tracking it on pen and paper. So they just digitized this process. And they had about 6 months of data. And they didn't know what was in there. And so when we met them, we said, well, let's just throw it in and have a look. And so they gave us their data. And actually, in the same week, we analyzed the engine analyzed that data. It prioritized some interesting patterns. We printed out the top 30 on paper, and we took it to them and had a kind of prioritization workshop where they were prioritizing if an insight was new, if they knew about it or they didn't, and if it was relevant to their business. And this was the first time that I really felt this is true agile analytics. A few days later, you are prioritizing insights. That never happened whilst I was at Deloitte. And what's interesting is that in this meeting was 2 people from the business side and 2 people from the data science, the analysts from the data science team. And it was really interesting because there was one insight, which was a rather simple one. And the business people said, oh, wow, this is really interesting. And the data scientist said, oh, I didn't even realize you knew that. So the insight was so obvious and so simple that the data scientists hadn't told the business guys because it was so obvious that they thought they already knew. And so it shows you also how it can help to bridge the gap between the business people and the data scientists. And it eliminates kind of bias, human bias from the whole process. So how does an automated analytics engine look like? Well, I wouldn't go into every box here, but this is a high-level architecture for an automated analytics engine. Each one of those boxes is probably a whole hour meeting in itself. So I would just quickly describe the kind of data flow, but not really go into detail in any of the boxes. So you have an engine core, which contains all the components for automating the data science process. Going into it, you have raw data, which is being passed through it via either a user interface or a REST API if it's automated. And then you have your import component, which is importing that data, detecting the delimiters, the type of file. It could be Excel file, it could be CSV file, it could be a database file. You have some data cleaning and transformation that's going on there to make sure that the data is in the correct format for being ingested by the data model. And the data model is what's serving then the rest of the analytical components. And of those components, you have a semantic understanding component. And these are classifiers for detecting if a column has geographic data, has price data, has cost data, has an ID. Actually, one really tricky classifier to get right is detecting if a column has ID values. So a column with IDs could have just numeric values. So how do you know that this column contains ID values and not something else like a continuous numeric dimension? So that's just one example of many. You also would have a data enrichment component, which is adding additional information into the table. Like, for example, if you have dates, you could enrich also with months, day of week, quarter, year, all these additional enrichments that one can do with dates. Also with countries, let's say you detect countries, you could also then enrich with publicly available data. Like for the World Bank example, it has many KPIs about each country. So you could also enrich with all this information fully automatically. And then once we've understood the data, once we've enriched it, then we can apply our base analytics. So all our descriptive statistics. Then once we've applied all our analytics, then we can look for the patterns. And this would be kind of the flow just for a core. And then you can have, you would add specialized add-on components if you had very specific things that you would, that a certain business might need. And then once you've done all your analyses, detected your patterns, then we're coming to the right of the architecture, and we are starting to visualize the data. You have the visualization component, which is drawing all your charts, adding all your annotations. You have a storytelling component, which is actually consolidating these different insights. Each insight, or you could call it a fact, by itself is not so, each one is valuable, but they're a lot more valuable when you add the context. So other insights that also give you a broader view and a more complete view of any specific insight. So the storytelling part is consolidating multiple patterns together into a kind of story fragment. And then we're starting to generate the output. We have a custom output generation component, which you might want to output in Excel. You might want to output in JSON format. You want to output your every chart as a PDF. You might want to output HTML files if you're browsing them in a web browser, these visualizations, and so forth. And one very important component is the user feedback and prioritization. So you've automated data science, and your engine is asking every question of your data. This could lead to many, many facts, thousands and thousands of facts. You need some kind of prioritization and some kind of filtering and recommendation. And so this is really important. Otherwise, you will just overwhelm anyone who's trying to look at the results. And for this, user feedback can be used. So a little bit like any recommender system, if people like or dislike certain slides, then you can feed this back into a recommendation system, and it can learn over time what type of insights are most interesting. And then yeah, you have the output. Okay, there is an interactive version of that there's the website down there, inspirion.com/architecture, and you can click on every component and it will give you more details. So what does this mean? So if we would look, there is actually a classification of automation levels for self-driving cars, and at level 0, this is actually a standard, these levels. At level 0, you have no automation, and at level 5, you have full automation. And currently for self-driving cars, we're at level 3, which means that it can handle dynamic driving tasks, but may need intervention. So this means that you have to have a driver in place in case something goes wrong. And if we would classify current analytics solutions along this this classification, you would get at level 0 your calculators. At level 1, you would have Excel, because it does help you suggest kind of graphs and these kind of things, but it requires full user assistance. At level 2, you would have your solutions like Tableau, which are going a step further than Excel. And then at level 3, you start getting your intelligent solutions like Microsoft Power BI, ThoughtSpot, and these are actually automatically applying analyses and recommending you things. At level 4, you would need the actually consolidating these results and putting them into these kind of storylines and giving prescriptive results back. That there are a few solutions at this area. We're one of them. Another one would be Palantir, and there are a few others, but not so many reaching the full automation. Actually, none reaching level 5 yet. Okay, so I would just take a short break here, answer a couple of Q&As before moving on to the second part of the talk. Drew, did you find any questions?
Yes, there is one question. That's from Carl, who asked about exploratory analysis. So I'm not sure exactly which content. I'm assuming that whole probing and hypothesis testing and the circling round with the appropriate feedback, how is that loop automated? Carl, is that the correct interpretation?
Okay. Let's assume it's the correct interpretation. Yeah. So the kind of feedback loop, because it is supposed to be a kind of balance between what the human is good at and what the machine is good at. The machine is good at crunching numbers. So let's let the machine crunch some numbers, crunch all of them, and then provide a sample of results to a user. So we do see this as an iterative process where the first iteration is not so accurate, but we can give a user some sample of descriptive statistics and see what they like, a little bit like Tinder, that you give them a sample and the user will say, I like this, I don't like this, I like this. And then we can start to understand what their interests are, what kind of patterns they like, what kind of analyses they like, and really what kind of questions they want to ask of the data without them actually knowing what the questions they have. And then we can propose some next steps, like some deep dives. Let's focus on this category. Let's focus on the outliers in this column. Let's focus on this region. So we can focus kind of action-based next steps, which will then get fed back to the beginning of the process, and then we can rerun the analysis, and then we'll get a kind of much deeper dive on a very specific area, and we can continue this loop until we really find the insights that we're looking for. Typically, we find that yeah, 2 or 3 iterations, and we get to the real meat. The first iteration is good at getting inspiration, and then yeah, you usually need another one or another 2 to really get to the meat.
Okay, so there's a few more questions came in. One from Connie to say the feedback loop you're just talking about, and I'm also assuming now that feedback loop is sort of pretty much driven by yourself and controlled by yourself, and so not truly automated. But let's not. So the question is, what's the risk of overfitting? E.g., if you're working with a specific client for a long time or specific types of analysis. Is there a risk your engine won't work as well?
Yeah, absolutely. There's the risk of going slowly, narrowing your search and going down a path, and then what you need to do is be able to jump to a different place, and we do this through recommending other insights which are kind of close, but in a different area. So if you think a little bit about the problem like a hill climb, we can suggest other hills that are similar that you might be interested, and this can avoid you getting stuck on one hill. Yeah. So actually, because you've analyzed the whole search space, you can actually work to avoid this kind of overfitting problem, and offer other areas of the insight space to make sure that you're not missing out on anything important. Yeah.
Guillaume, there was another question: is there a requirement that the business need to meet from a data management perspective before Insperian become an option, or is it something that would add value?
A data requirement. So the system currently can only work on flat tables, and other than that, the idea is that there shouldn't be any kind of requirements up front.
I think what Esti is asking is, does it help that the business have an idea what they're looking for, or would you guys simply come in and go berserk and produce some stats, results, and suggestions?
A bit of both, actually. So it's good to have an initial idea of the kind of business people always have questions that they want answering, but they also want to know what else is out there. So you do have both, and you can guide the analysis to give you certain answers to certain questions. But you also don't want to only give them those answers. The whole value of this is to look outside of your assumptions and your knowledge, and find things that you might not have thought about. But you definitely have to also answer the questions that they have. Otherwise, the business are disappointed. Yeah.
Oh, absolutely. So there's a couple more questions. I'm going to read them out together because I think they are related. And the first one was, how frequently would you recommend revisiting some of the steps within the process to cater for data changes, or if when data requirements evolve? And then there was one also says, so perhaps garbage in, garbage out. So you actually need to ensure your data is of a good quality. And then the other one would be, what is there an optimum data set size?
Okay. So I tried to go through them quickly so that we can continue. So as for the first part, it is important to detect changes, and so you do this by, I mean, by it depends on also on your sample size. If you give it enough history, you can look at the changes over time. The system will look for deviations over time as things change, and so that would depend on how far you're looking back. If you're only looking back 1 week, then you won't find any deviations if something changed a month ago. So you do need to supply enough historical data. And as for size of dimensions, you could supply too many dimensions. So the width of the table could be too big, and then you have too many results at the end, because the complexity is increases exponentially with the more dimensions. So yeah, you have to make sure that you have enough historical data, and you have to be careful about not submitting too many columns to begin with. As for the garbage in, garbage out, that is true to some extent, because it's not black or white. And typically people answer this or give a very black and white statement to this. If you don't clean your data, you will get garbage out. Yes, that is true, but there's a spectrum. Your data is to some degree dirty, but to what degree is it dirty? Because if it's 99% clean, then your confidence of your results is very high. So you can submit a little bit of garbage, and we do a quality assessment. It's based on the IBM Watson quality assessment, and it's looking for all the common data quality issues, and there's a score. And if your score is very low, then you have less confidence in your results. And then, of course, the next step would be to clean up the data. But if you've already done your quality assessment, you can prioritize which cleaning actions will increase the quality score. And so you don't have to have 100%. You will never have 100% clean data. The question is if it's clean enough, and automation will help us understand if it's clean enough or not.
Cool. You want to
so
push
can I
on?
ask just I mean, typically what we do is define a data quality expectation. Is there some way of feeding that into the system so that the system doesn't go for ultimate and it's allowed a certain range to be acceptable?
Yep. Yeah. This is getting more technical than I thought it was going to get, but we have two very important dimensions. One is confidence and one is relevance. And you can set these are just two thresholds that you can set to whatever you like. We have an internal default confidence threshold, but you can make it lower or higher, and you can set that. And basically, Analyses will not continue if it doesn't reach your confidence threshold. And the same with the relevance. We assign a relevance to every insight, and if the relevance is too low, then we won't show you that because it's not interesting for you. Yeah.
Okay. All right.
Good. Then I'll continue, and we can have more questions at the end. So I'll try and skip through a bit quicker through the second half. So why is this interesting? Well, for many people, it's going to save time at the beginning when you're exploring data, when you're trying to think of your assumptions. At the very beginning of any kind of data science project, this is really helping you give a kind of view, a scan of where the threats and the opportunities could be. And one client of ours was saying, well, this is saving them the first 2 weeks of every consulting project. It's not taking the consultants away. it's just saving the time from the beginning. Actually, the most valuable work of a consultant is thinking about the results in the more strategic part. So it's a better man-machine balance in the end. It's avoiding human bias. This is one thing that data scientists and business people fall into quite a lot. Maybe you know the streetlight effect, but you have someone who's looking for a coin, and there's a policeman saying, did you drop it there? And the guy who's looking for the coin, he's saying, no, I dropped it 2 blocks down the street. But he's looking there because the light is better, so it's easier to see. And we do fall into this trap quite a lot, where we tend to look where it's easier to look, and avoid the really hard parts. And also, as part of the kind of learning aspect, and different people want to see different things. You have an analyst, which is very interested in the details and the more descriptive statistics, and then you have business people who just might want directly the more prescriptive stuff right from the beginning, and they're not so interested in looking through all of the descriptive, and just want you to get right to the point. Actually, and sometimes the different groups of people don't realize that they like different things. We had one example with a multinational insurance company. We did an analysis with the analyst, and he did a prioritization of the results and chose his top 10. And he had another few which weren't so interesting, but he kept anyway. And then one day he met with his boss, who was a board member of this insurance company, and he showed him his results that he found really interesting. And the board member actually found the most interesting, the one that he had put at the back of his pile, that he found not so interesting. And he found it so interesting, this one side, that he actually took it to a board meeting. And the analyst was a little bit shocked that he had deprioritized this insight, and it was actually the most interesting one for the board member. So we don't even know that sometimes that we have these different views on relevance. I will give a very quick demo now, just to show you an automated analytics engine in action. Okay, so it can run as an automated backend system with a REST API, or it can run as a ad hoc analytical solution via a web browser. And you get an account, you log in, and you can do this in a very opportunistic way and just find yourself tables that you want to analyze. I have an example data set here of sales and profit data. We'll have a look at the data shortly once I've started the analysis, because it takes a few minutes to run. So we can just choose an Excel file for analysis, and we can start the analysis. And the first thing that it does is classify the input file and the format of the table, and then what it will actually do, it will ask you for a bit of guidance, and so we've imported we've detected one table within this file which contains 1,000 rows with 10 dimensions: category, order date, manufacturer, product name, and so forth. We have applied a certain relevance to every column. We see that profit we classified as a high priority one. And here we can add a bit of guidance and say, actually, you know what, segment I'm really interested in, so I'll put that to high priority also. And And the semantic part of it is here. So here we've classified these columns of whether they're summable, segment and state we've detected as IDs, and we can help the system out a little bit here. We can say profit. We can say, okay, it didn't detect that this is summable, so I will help it a little bit and say that that's also summable. And then I will start my analysis. You see at that guidance step, you can also correct the system if it did anything wrong. And you can also tell it to focus on specific categories or anything like that. The table that we're analyzing is a publicly available data set. It's a rather nice data set for doing kind of business analyses. It comes from Jason Krantz from a company called Strategy Titan, and it is actually one of the better publicly available business data sets that we found. It contains information like category of the product, the order date, manufacturer, some text on the product name, so some numeric columns, profit, quantity, geographic dimensions here, some data quality issues here. We've got a div by 0. And then, the analysis is taking place. It's cleaning up and transforming the data. It's then enriching the data. And then it starts doing all its analyses, and this is where it's aggregating the data, basically doing all the pivots that are possible. This will take a minute or two. In the meantime, I could actually show you some of the files that it's generating as it's working. So it's already done a data quality assessment, because that's one of the first things that it does, and it's already output a data quality report. And if we can just look at that, and it's completed 52 checks, data quality checks, and it's found a few checks which are below 0. And these include things like here we have the check was check for erroneous data, i.e. the values don't conform to the inferred data type. So we had an erroneous div by 0 value, which we've ignored. We also have other checks like check for missing values. We had in column sales, we had 2 missing values. And then we can calculate a quality score. And this quality score is, as I mentioned earlier, it's based on the IBM Watson quality score. And then we can actually recommend mitigations for each one. So we can say you can review the automatically handled import issue. You can assess the impact of the 2 missing values. And then we can prioritize those. And the analysis, okay, so it's finished all of its analyses. And now it's doing the pattern. It's looking for patterns across all of the analyses now. This is the part of the process called searching for insights. That's coming along. And then after that part, we will start generating the output. In the meantime, I can show you other parts of the generated data. So this view is telling you how the quality score was generated. So you get a little bit more information in this table about every column. the data type, which was classified, text values, date time, whole numbers, fractional numbers. We have annotations that we added to the columns. We have semantic ontologies or semantic classes that were detected. This is a classifier for business concepts. So we're detecting transactional dates or non-transactional dates, product from the retail domain. We have profit from financial services, and these are all, each one is its own classifier, which is understanding what the column is about. Yeah, we have our relevance calculation here. We have, yeah, then other descriptive information about the number of populated cells, the data quality score, and so forth. Okay, so we are nearly done. We're now generating the output. Which will okay, we're still generating all the output. Actually, for analyses, usually generating the output takes the longest. Drew, if anyone has a question now, I could quickly answer it.
Yeah, there are a couple. So Jan Borman was asking, wouldn't data quality skew some of the dimensions? And then he asked, is there an easy way to manipulate the dimensions for better quality? And then Howard was asking, is there a public semantic ontology?
Sorry, the last one about the ontology?
So yeah, that was from me. I see you got a semantically defined ontology that does the classifying of the attributes. Is that, do you stick to a one that's from a .org, or have you built your own?
So we've it's kind of a hybrid. We based it on a standard for industry. I can't remember that sounded from the top of my head, but we've had to customize it because for every client they have additional or slightly different classes, and so we kind of have a hybrid where we have both the standard and customized based on clients that we've been working with. It's rather easy to add new ontology classes, and then using those ontology classes, you can then define other things like custom transformations or enrichments or analyses. Yeah. As for the other question about data quality,
so I'm going to ask Johan to ask his question because he's added a third one in now. So Johan, do you want to ask those questions?
Yes. Okay. So I'm actually sorry for chipping in like usual. Yes, actually, I'm just, because now this is all very, very nice. Well, actually very, very good because look, actually, obviously in our world we work with dimensions, okay, and quality is that not, because actually wouldn't bad quality actually skew those results that you can't really make sense? And like, is there easier way or an easy way to actually change things or manipulate things that you can start making sense actually out of this, like, data science? It's just something that I'm thinking about on the fly.
Yeah, no, absolutely. I mean, data quality issues will skew your results. The interesting question is, how much do we estimate that it's skewing the results? If we have, I mean, in this example, we have 1,000 rows, and in the sales column, we had 2 missing values. So 2 missing values from 1,000 it is actually not so many. So you could give a probability that it's not going to skew too much missing those values. You should still be able to get a good enough kind of model without those 2 values. It's certainly enough to start at the very beginning of any analysis process. If you can already get a view into the data on the first day, then the lower confidence is kind of worth it. If you set your threshold that you don't accept anything below, if your confidence is below 95%, then you don't accept it. Then then you would need to look into the data and see how you could fix it so that you get a higher confidence. The thing with most analytical solutions, they will not continue unless they have 100%. Okay, and so the analysis took four minutes in the end. And what we have is a landing page with consolidated insights as kind of stories. And this story is the data quality assessment. And so it's giving us a summary of the issues in our data. We had erroneous data, we had missing values, when we had a missing primary key. We can give the detail of the issues with proposed mitigations with a suggested priority. And given that we can actually prioritize, we can do almost an Eisenhower matrix on the data quality issues and decide if we fix them, delegate them, or ignore them even. Then something maybe more on the business side would be something like the top priority dimension analysis, where we're taking profit as our top priority dimension, and we're giving a bit of descriptive summary of that. Profit is going down over the years for profit. That's not good. We can look at different time resolutions. We can look at the geographical. Where is profit coming from? Mostly from New York and California. Okay, and we can. Next steps would be to assess the data quality issues. Yeah. And if we really want to explore one by one and not in this story view, then we can actually go through each insight and review each one. And we can say, we like and dislike certain analyses. And then next time when we're running these analyses, we will have a slightly different recommendation. And we can filter by a certain tag. So I want to see all my outliers. So we can look for anomalies or search by any kind of tag, dimension based or analysis based. Okay. I would not continue with the demo, just to quickly finish, because we're already 10 minutes over. The next part of the talk would have been the 3 real-world cases. Drew, Do we have time, or will we go to the last Q&A?
I'm personally more than happy to carry on, and I'm sure that those people that do need to leave would go. Howard, I'm not sure you're thinking.
Yeah, I think let's keep on going. If they would like to, maybe we can organize another session. So I'll actually ask that tomorrow, Guy, and then if they would like to see it, then let's have another session.
Okay, so your proposal, Howard, would be to do another session, maybe on the real world.
Let's keep on going. Let's finish
Okay.
for those who can. If there is a big demand, we'll try to get you back in again.
Okay, then I'm going to very quickly skip through 3 real world examples, just to kind of put this into context of how such an engine would be used in the real world. The first of the 3 examples is it can be used as a back-end process automation. For example, for a Big Four auditor, we are building an ontology for the expense appraisal process with some custom rules that enrich the data, and these custom rules are based on their expense policy. Because right now they have around 20 FTEs which are appraising their consultants' expenses, which pre-pandemic was a lot of expenses, and some thousands every week, and this was a 20 FTE process. And what they had to do was, for every expense, check against the policy whether it should be accepted or not. And so we have transformed that expense policy into some custom rules for them. And with this, we can then apply both rule-based rules and machine learning. We built some classifiers as well. For example, they have free text field to explain why they needed to take the taxi. So we built a classifier to detect if the reason is acceptable or not. And in total, there was around 35 neural networks, and the rule-based rules, there was probably about 100 or so. And in the end, we managed to get a more than 95% decision accuracy, and achieve around a 75% cost reduction, with also a speed increase, because when you've automated the process, you are able to approve decisions quicker, and the consultants will get their expenses paid quicker. Another very nice real-world use case is fraud detection. So typically, fraud is detected via rule-based systems. So that you define a rule based on fraud behavior that you've seen in the past. The problem is that fraudsters are a little bit cleverer than that, and they're constantly changing their behavior as soon as they know that there's a rule for certain behavior. So they're always a step ahead, and the banks are always a step behind. And so you would also want to combine both rule-based analytics with kind of unsupervised machine learning for detecting anomalies. And this is what we did for BNP Paribas. And we helped them detect possible phishing cases. Phishing is where somebody steals your account details, logs into your account, and takes your money out. And so you can detect kind of strange behavior on someone's account, which could suggest that somebody else has logged in that's not the owner of that account. The key thing for this bank was to stop reduce the possibility of cyber threat, and also reduce their insurance costs. And the third real-world example was very much an opportunistic analysis. So again, for Deutsche Bahn, this is where we analyzed the maintenance process data, and we found some interesting patterns that they weren't aware of. And actually, based on these patterns, they were able to adjust certain things on their stations to make for a better experience for travelers. Okay, so that was the three examples. Very quickly. Along the way, we've won some interesting awards. And then I would switch to the last Q&A. And thank you all for listening. Also, I just mentioned that if you think of additional questions or we run out of time and you have to leave, feel free to click on this link and book a 15-minute coffee with me, and I'd be happy to answer any further questions. I'll give that link to Drew, who can share it out. And you can basically, from that link, book a 15-minute slot with me to have a coffee and ask any further questions you might have. But I'm also here now for additional questions. So thanks, Howard and Drew.
Sure. From my side, I'm blown away. This is really good stuff. Guillaume, a question: how important, or what have you guys running behind it in terms of horsepower, the chip processing and the rest to churn these numbers?
Yeah. So the core is built in Java, and it's a proprietary probabilistic reasoning system that we've built up, and it can run on any machine. What it does need is a lot of RAM, because it does a lot in memory. Most of its processing we like to run purely in memory if possible. If we can't, then we will write to disk. Given that we do a lot of analyses and it can be rather large, then lots of RAM is very useful. But today's demo I did on my laptop, so you can actually deploy our engine on a laptop and run it on smaller data sets absolutely fine.
I guess the other question which is likely to come up is, how would an organization go about engaging with you guys to do a proof of concept, to explore some of your concepts?
Yeah, so you can just reach out to me.
15-minute coffee, Drew.
Yeah, 15-minute coffee.
15 minutes, Howard.
Just to start. Then the fun goes on from there.
I see a beer,
yeah.
But basically, we can do a very quick. The typical thing that we do is just a very lightweight POC, which consists of we would have a 30-minute talk with whoever's interested and discuss their current use case, look at how they can source their data, and then once we've identified a use case and the data that belongs to that use case, then literally you can just submit it to our engine, and we can analyze it. And then what we like to do is guide you with the kind of 2 or 3 iterations, just to make sure that we're getting to the really valuable stuff. And yeah, it's a rather lightweight thing, which can take 2 or 3 days, with including the 1 or 2 iterations. Yeah. For a more for a very specific, more kind of custom problem, then we probably could do a prototype of solving a very custom problem within 1 or 2 weeks. But that all depends on how custom is the problem.
I see that Connie's asked another question. She's asking, are you able to explain where the insights are coming from? I think just for in the interest of transparency.
So I think this comes also to the ethics. So explainability. So if you give an answer, and then how do we see how do you explain how the answers come about?
Yep. So actually, given that the system is reasoning with very specific decisions at every point, and deriving a confidence for every kind of reasoning decision that it makes, we can be very, very specific about the kind of reasoning chain that led to any insight. And so for every insight that we have, there's a full reasoning chain behind it that explains how we got to this fact or this insight. We were speaking at one time with a software vendor for accounting tools in Germany, and we showed them the reasoning chain for one decision, and they actually said this is more thorough than the human audit trail, and actually that's because the system is if it looks like a black box, but actually I would say it's more of a glass box, in that you can actually see every decision that it's made and identify a point where it made a wrong assumption, because we also log every assumption that we make, and so the explainability is there.
Has anybody else got any questions at the moment? Mishima?
Actually, Drew, actually, Hanya, sorry.
Nothing from my side, Drew. I think. Sorry.
Okay, Johan, you want to ask a question?
Yes, please. Actually, I just want to get back to my other question. We didn't get through it. I may have missed it, but like these data sets, do you run this on something like Hadoop, or actually what data sets? Because I missed the first like half an hour. And is this also, well, in the same vein, would most probably be, I assume, actually denormalized information is most probably the best to run it from.
So we're running on can be large flat tables. We don't have the Hadoop integration right now, but we could do. Right now we connect to a relational database, CSV file, Excel file, and what we're doing is we are importing that into our own internal data model, and running all the analyses there. When we're not running Hadoop. No.
Okay.
And that's the point about the needing a large amount of memory, because the larger your data set is, we need enough RAM to analyze it. A rule of thumb is that you would need 10 times the amount of RAM to the size of your data set. So if you have 1 gig of data, you would need at least 10 gig of RAM. yeah, so you can roughly multiply it by 10 by your RAM requirement. To run in memory, that is. If we can't run in memory, then we will just output to a database and look up the data from the database. Then things slow down a lot.
Okay. Are there any other questions, or Howard, do you want a couple of comments before we shut down? I think Howard's gone missing in action.
Sorry, I went on mute. Sorry about that. Yeah, I think for me, I really like what's been done. I do buy into the scenario of the amount of data wrangling that's happening, and this is a real issue that people are fighting with, and that standardization of the data model. So I would love to understand a little bit more on a more complex data model, or is this really focused on a wide data set of basically a single data set with all the dimensions in there? Is that the right way to handle this?
So you definitely have a point with a kind of lack of standardization for kind of data quality and kind of shareability of data, and just to go a bit further. So we do handle different types of tables outside of ideally we want flat tables, but if you don't have a flat table, we try and classify the structure of that table and then transform it into a narrow table. So you can submit multiple tables, and we will automatically try and infer the data model. You can even be very opportunistic here and submit two data sets from totally different sources. Because what we do is exactly that. We try to standardize the data sets so that when you're looking for the relationship, you're looking for the relationship on the standardized tables and not the structure or format that they were originally. And this makes us a lot more robust when looking for relationships. So for example, one basic example is when we combine business data, someone's own internal business data with KPIs from the World Bank. If you would download the World Bank data, it's pretty difficult to use because they have a structure where the time domain is in the columns.
It's in a messy format. You got to go to tidy first, and then
Yeah, so you first need to transform that from a kind of time series based column based table to a narrow table, and only at that point can you then start joining it with other tables. And so we detect these kind of different structures and we standardize. And then that's what allows us to increase our chances of being able to join tables and find the relationships between them. Another interesting kind of tabular structure is the profit and loss statements, because they're hierarchical. You have kind of subtotals, and this is this is really tricky. But actually, for another Big Four auditor. We're working together on actually being able to make sense of these kind of tables and turn them back into narrow tables, so that we can do further automated analyses on them.
Thank you.
The nice thing about working on such an engine is that every time you kind of build the classifier or a part of the reasoning chain that standardizes something, you feel like you never have to do that thing again manually.
Right.
Because you're going from general to from messy to kind of standardized, and as you're the more the more you're kind of covering, the less you ever have to do manually, and it's actually quite satisfying doing that.
Yeah, that's great.
All right. I think if there are no more questions, I personally have found this to be a fascinating session. I'm definitely going to book a coffee with Guillaume. I'm sure Howard is as well. Howard will put out a note tomorrow, and he would share the recording once we get the slides. So I think from my side, Guillaume, it's been an absolutely fascinating session. I'm really impressed with what I'm seeing, and realize how much time can be saved, and also how much more consistent the result set can be, because you're not relying on different human interventions at different times.
Yeah.
Yeah, very often the kind of work that you're describing gets sent to some junior people who don't really have the indication or the application to get it done properly. And then you go back to the questions about, so how good was the data set and how good are the results? So no, this is really impressive.
I was that junior person at Deloitte, and I made plenty of mistakes, and actually I introduced risk into the project because yeah, I mean I still had a lot to learn, and I probably made a lot of wrong decisions and did the wrong analyses and did the wrong deep dives, and yeah.
I think we've all been there, and we've still got to watch it. Don't go there again.
Yeah.
But yeah, so from my side, absolutely, thank you so much for giving us the time. And as Howard mentioned, I think we would probably like to schedule another one where we maybe do a slightly deeper dive.
Yeah, we could do a deeper dive on a specific topic, like one particular analysis, and go through the reasoning steps for a whole story.
All right. So from my side, that's me. Howard, do you want to do the close?
Yeah, thanks everybody. Thanks everybody for attending, and hopefully we'll see you again on Wednesday. And if any of you had any further questions and stuff like that, let's put it together on give us some feedback, and then we'll chat to Guy on seeing if we can set up another session. But thanks everybody. Thanks for joining.
Yeah, from my side, Guillaume, if you want to join us on Wednesday, you're welcome too. 4 o'clock.
Okay, thank you.
Scott Taylor and telling the data story.
See if we can automate that.
Yeah.
Thanks, guys.
All right. It's been a pleasure.
Thank you.
Bye.
Bye.